Good morning all. Today we'll see about data link layer function, that is MAC protocol. One of the important function of data link layer is media access. We'll see about the protocols that are used to decide which station will occupy the media. We'll see about LAN, yes, so local area network. One of the function of data link layer is media access control. Yes, so media access control is accessing the medium. We know that bandwidth is a precious resource, and many of the stations will be competing for sharing the common medium, that is to send the data. Yes, but we cannot give access to all the system. If we give access to all the system, then it will lead to collision, and probably we have to retransmit all the frames what we have sent. Yes, so in case of LAN architecture, we have seen about various topologies. Yes, so for each of the topology, we have got various protocols. Yes, normally every protocol has got an IEEE number. So if I say 802.3, that means it is Ethernet or CSMA or CD protocol. 802.4 is token bus. 802.5 is token ring or FDDI. 802.11 it is wireless LAN, and Bluetooth 802.15, that is also one of the LAN protocols. Yes, so all these protocols are very important and can be asked for your exams. Yes, so one of the important protocol is carrier sense multiple access with collision detection. It is the normal protocol which is used for LAN. Yes, we'll see what it is. Before going into details of the protocol, we'll see what is medium access control. Yes, so we have got a single shared medium which is accessed by all the stations in the LAN. Yes, and every station will compete to acquire the medium. Yes, the basic protocol is Aloha. This is the protocol which is not currently used, but just to show how the protocol evolved. Yes, so in case of Aloha protocol, if a station has anything to transmit, say I am some station A, I've got a frame to transmit. Yes, I'll not see whether the medium is free or any other station is currently transmitting. Just I'll transmit whenever I got a frame. So what happens is it leads to collision. Yes. So this is not the right strategy, where the utilization bandwidth was only 18%, meaning which all other frames have to be retransmitted. The second protocol, how this protocol was changed is, as every station transmit at a random time, it will lead to collision. So what they did in case of slotted Aloha was, they divided the entire timing into slotted timing. Yes, say slots of 15 seconds each. Yes, any station that has anything to transmit should start transmitting only at the beginning of a slot. Say if I have got anything to transmit, I cannot transmit when I have my frame ready. Instead, I'll wait for a beginning of the time slot. Yes, I can transmit at the beginning of 0th second, 15th second, 30th second. So this minimizes the chance of collision. Yes, so because before transmitting, anyhow, I'll see if the medium is free. Yes, so 0th second, I'll see. If some other station is transmitting, I'll refrain from transmitting. Again, at the beginning of 15th second, I'll see if the medium is free. If it is free, I will transmit. If it is not free, again I will wait. Yes? So that is the slotted Aloha protocol. This protocol evolved into carrier sense multiple access. Yes. What is a carrier? Carrier is the medium. Medium, the other name of medium is carrier. Yes. So if a station wants to transmit, what it does is it will listen to the carrier. It will sense the carrier. Yes, it will sense the carrier and then will access the medium. Yes, so that's why it's called as carrier sense medium access. Yes, so what happens here is, in case of Aloha, it transmitted whenever the frame was ready. In case of slotted Aloha, it transmitted at the beginning of a time slot. Yes, in carrier sense multiple access, you listen to the you see to the steps here. First, it will listen if the medium is free. Yes, that is sensing the carrier. If medium is free, then it is allowed to transmit. If two stations sense the medium at the same time, both of them find that the medium is free, but both start transmitting at the same time, then this protocol also there will be collision. Yes. So how it knows that a collision has happened? It will wait for an acknowledgement. If there is no acknowledgement, it will retransmit. So this will improve the utilization of bandwidth. Yes. So if the medium is free, it is allowed to transmit. What if the medium is busy? Yes. So it has to listen to the channel continuously and wait until the medium is free. Yes. In order to transmit. Yes. So here there is a provision for collision detection. Yes. So the station listens while transmitting. If medium is idle, it will transmit. If the medium is busy, then it will wait until it is free and then will transmit. If suppose it detects a collision, then it will stop the transmission, and before restarting the transmission, you should know that it waits for some random time. Yes. So this type of protocol evolved after slotted aloha protocol. That's not included in this presentation. It is called as persistent protocol or P persistent protocol. Yes. So meaning which even if the station is free, even if the medium is free, a station will not transmit immediately. Instead, it will wait for a random amount of time, or it will wait for a time slot which is based on probability. Yes, it will refrain from transmitting with a random probability. That is, I am station A, someone else is station B. Station B, A, I will choose a random time slot of 5 seconds. I will wait for 5 seconds. Station B, it will wait for random of 10 seconds. Yes. So when we transmit again, no, the probability of collision is less. Yes. Do you understand what is meant by P persistent protocol? Say station X and station Y is finding that the channel is free. So if both of them transmit immediately, we see that there is collision. So what I choose a random time and station Y chooses another random time. Yes, both of us will start transmitting after that random time. So after 5 seconds, I will transmit. After 10 seconds, when Y tries to transmit, you will see that already a station is transmitted. Therefore, it will stop from transmitting. That is called as P persistent protocol. Yes, the CSMA CD2 follows that principle. Even if the channel is free, it will not transmit immediately. Instead, it will wait for some random time before transmitting. Yes, watch this picture carefully. Yes, here we have got four stations A, B, C and D. Yes, so you can see at a time slot T naught, A is transmitting. Yes, and there is some signal in the bus. I told you in physical layer the transmission will be 0 and 1. So whenever there is 1, that means there is a voltage of 5 volts. Yes. So you know that there is transmission. That's how a channel or a station can detect if a channel is busy or not. If there is some voltage level in the channel, that means that some station is transmitting. Yes, if A is transmitting and D is sensing the channel, means it cannot sense any signal, because at this position it is still 0 voltage, because it will take some time for this signal to get transferred until D. Yes, so only at a different time slot D will be able to sense that A has transmitted. Yes, so if you see at time T1, A's transmission is has crossed B, and therefore B can detect that A is transmitting, and at the same time T1, you see C wants something to transmit. Yes, so what it does, C senses the channel, it finds that the channel is free, and therefore it transmits. Yes, because it cannot detect this A's transmission yet. Yes, so it is also transmitting. You see that at a certain time T2, A signal and C signal collides. Yes, so there is a collision here. Yes, so if you see at time T3, yes, so A's transmission is there, C's transmission is there. Yes, A is also detecting the collision. Yes, so at time T3 itself, T2 itself, C can detect the collision. Yes, but still it takes some time for the system A to detect the collision. Yes, so it's depicted here. You can see at time T1, A's frame is getting transmitted. Yes, so at time T2, C is also getting its frame transmitted. So at time T3, there is a collision there, but this collision and A is also transmitting at 5 volts, C is also transmitting at 5 volts. Somewhere it becomes 10 volts. We call it as collision. Yes? So now this 10 volts to transmit to A, it takes some more time, and at time slot T4, A can also detect collision. Yes? This is the frame format. Yes? So every field will have a source address, destination address, length of this total frame. Yes, so the frame check sequence, it is like checksum. Preamble is like header. Yes. So these are various formats. Yes? So you would have heard about 10 base T, 100 base T. This depends upon the type of the cable used as well as the speed. Yes, this 10 denotes speed, 10 Mbps. Yes, base, it denotes it is baseband signal. T denotes the type of cable, twisted pair cable or the length of the cable. We also have 100 base TX, 100 base fiber optics. Yes, 100 Mbps bandwidth. Yes, so next we have just seen about CSMA bar CD. You know, LAN topologies. We have seen about token bus, token ring. Yes, so and other topology. We'll just see how this medium access. Now, what we are seeing, it is the functionality of medium access. Yes. So now, in case all the stations are connected by means of token bus, how does a station acquire the channel? Say in a LAN there are 8 stations. Yes, how does a station know that it can transmit at a particular time? Yes, so you see here there are 8 stations. Yes, so whichever station possess the token is allowed to transmit. Say at the beginning a token will be generated. Yes, so every station will hand over the token to the subsequent station. Say one, if it has it will generate a token and pass it to all other station. If it has nothing to transfer, it will give to 2. If 2 has nothing to transfer, it will give to 3. Yes, if 3 has something to transfer, it will capture the token, it will not give it to 4, and instead it will transmit its own frame in the medium. So what does it mean? Whoever has the token in its possession is allowed to take possession of the medium and transmit. Now station 3 transmits. Yes, so now whatever is transmitted by station 3 is received by all other station. After the receiver receives, it will send an acknowledgement, and after receiving the acknowledgement, the station 3 will release the token and give it to 4. Yes, so it is like a round robin manner, it will go. Yes, so here every station will get something to transfer. Yes, this token bus technique will work well when there is light load. In case there are 20 systems under light load and a station has something to transmit, it has to wait, if it is a 20th station, until the token is passed from station 1 to 19, even though all 19 stations doesn't have anything to transmit. Yes, that is the disadvantage of token bus. I repeat, in case of token bus, the station whichever possesses the token has the right to transmit. Yes, this works well when the load is high. That means when more number of stations have got something to transmit. Under light load, the station has to wait for a long time, even though the other stations have nothing to transmit. Yes. So next is token ring. You know, the token ring, it's the token bus with last two systems. Instead of the terminator, it's again connected in a circular fashion, so that if there is any connectivity disruption, still the connection can continue. Yes. So here also it uses the token passing mechanism, where one will generate the token and circulate. The station will wait for the token. So whichever station has anything to transmit will capture the token, will change one bit of the token to indicate that it is a data frame. It will attach its data to the frame and then transmit. Yes. So here too, after receiving the token again, then token will be regenerated and given to the subsequent station. Same as token bus, only thing is last station is again connected to the first station. Same as token bus, the efficiency under light load it is inefficient. Under heavy load it works fine. Yes. So this illustration depicts the formation and the circulation of the token. Yes. So this is the token. You see, it is transmitted from one station to another. Yes. So whenever a station has anything to transmit, say C has anything to transmit, it will capture the token and then it will send the frame. Yes. So suppose it sends a frame to D. After D receives the token, receives the frame and sends acknowledgement, C will once again generate the token and then retransmit. Yes. So again, this is the frame format. So frame format all, it's self-explanatory. You need to by heart the meaning of each of the bit. Yes, FDDA is one form of token ring. Yes, so in case of token ring, there is only one ring. Yes, in case of FDDA, there will be two rings. Yes, so that gives additional reliability. Plus, in case of FDDA, the transmission medium cannot be cable. It is fiber optic. Yes. This FDDA is used in case of fiber optic transmission in order to include the efficiency. So here you see there are two rings. One is the primary ring, another is the secondary ring, so that when a particular station has any issue, still you can see the transmission continues, and because of the fiber optic medium, still the speed is very high. In case of Wi-Fi, there are two different types of network. One is the basic service set without an access point, and another is basic service set with an access point. Yes. So without an access point, suppose we have 4 different laptops in our class. We connect. Have you ever tried connecting two laptop in a wireless fashion? Yes, so that is called as an ad hoc network. Yes, you need not have any cable. You can just form a network among 4 different wireless devices. Then it is called as an ad hoc network. In case of infrastructure network, you know, we have a Wi-Fi router or access point in your home through which many of the devices can be connected together. Yes, so this is called as infrastructure based network. Yes, we can always connect number of wireless LANs together with the help of a distributed system. Suppose each of our laboratory has an access point, and we can always connect all this access point together to form a distribution system, which is a larger network. Yes. So here, this is the MAC protocol what we are using. Yes. So in case of Wi-Fi, there are not in case of Wi-Fi, in case of any wireless transmission, there are few problems which are not present in wired transmission. In case of wired transmission, always there will be some problem. In wireless transmission, there are certain problems which are not persistent in the wired transmission, because in wired it is channel through which we are transmitting. In wired transmission there will be some interference, there will be some noise. Yes, so there will be some hidden station and channel coherence. Yes, so here in case of hidden station problem, you see there are three different systems, A, B and C. Yes, so if B is here, this is called as transmission range of B. Yes, so within transmission range of B, another station also transmits, then it leads to collision. Yes, so if A is present within B's range and A and B transmit at the same time, it will lead to collision. Similarly, when A and C transmit at same time, it will lead to collision. Yes, so what is hidden station problem is, suppose A, B and C are located in this fashion. Yes, so now B and C are out of the range. Yes, when B is transmitting, as in case of wired channel, it will sense the medium, it will find that the medium is free and then will start transmitting. Yes, at the same time C also will sense the channel, because C is out of range of B, it cannot detect that B is transmitting, and therefore C will also transmit at the same time. So what will happen? Collision will occur somewhere here. Yes, understand? What is hidden station problem is, when two hidden stations, in this case B and C, transmit at the same time, it will lead to collision, because C is out of range of B. When C wants to transmit, it senses the channel, it cannot detect B's transmission and therefore will result in collision. So how to avoid this? With the help of certain control packets which are called as RTS and CTS. Yes, RTS is request to send, CTS is clear to send, which is an acknowledgement. So here, whenever a station has anything to transmit, the station has to send a request to send packet. Yes, when A receives it, it will immediately send a clear to send packet as an acknowledgement. Now you see, as in the previous case, B and C are hidden stations. Yes, so now as C receives this clear to send, it will know that someone in vicinity of A is transmitting to A, and therefore C will not transmit to A. Yes, so this is how hidden station problem is avoided. I repeat, when B has anything to transmit, it will send request to send. A in turn will acknowledge it by means of clear to send, which is also received by the hidden station of B, which is C. Now C knows that someone else is transmitting to A and A has given its acknowledgement. Therefore C will stop transmitting until the end of B's transmission. How C knows how long B will transmit after the CTS packet? A network allocation vector. Yes, so that is like an array will be transmitted again by B to A, which contains who is transmitting to who. Yes, B is transmitting to A and how long it wants to transmit. Yes, so by seeing this network allocation vector, C will stop its own transmission for next few seconds. Yes, so this is exposed station problem. Yes, so here you see again B wants to transmit to A. Yes, C wants to transmit to D. Yes, so I repeat, B wants to transmit to A, C wants to transmit to D. Yes, or you assume that A has something to transmit to B. Yes, C has something to transmit to D. Yes, so in that case A and C are within its own range, transmission range of A. C is also present. Yes, what C will think, A has got something to transmit, so if I transmit, it will result in collision and therefore C will not transmit. Yes, but in this case A is transmitting only to B. Yes, so even though C is transmitting to D, there will not be any collision. Yes, so this is called as exposed station problem. Yes, since C is exposed to A's transmission, it will not transmit to some other channel out of range, thinking that it will collide because it will know that A is transmitting. Yes, how to avoid it? Again, with the help of same RTS and CTS packets, A will send RTS packets for which B alone will send the CTS. Yes, so now C doesn't receive the CTS packet, therefore it will not know that A is receiving some transmission from B. Yes, so when C has anything to transmit, it will transmit the RTS packet. Yes, and D sends the CTS packet. So C also can transmit the data. Therefore, expostation problem is avoided. I repeat, if C thinks that A is transmitting and doesn't transmit to D, then time and bandwidth is wasted. Yes. So how it is avoided? Whichever channel wants to transmit will send the RTS packet, for which the channel to receive alone will send the CTS packet. Since C is out of range of B, it will not receive the CTS packet. Therefore, when it has anything to transmit, it will send RTS packet and receive the CTS from D, and then will start its own transmission. Yes. So here we have some, I told you when a station has anything to transmit, it should wait for some random amount of time. Yes. So that random amount of time we call it as diffs and sifs. Yes. Some short interframe space and distributed interframe space. Yes, just this is a short time random time, this is a long random time. Yes, so these are the time period for which it has to wait. Yes, as I said you, this network allocation vector will have all information as sender address, receiver address, and how long the transmission will go on. Yes, so this is the final CSMA bar CA algorithm. This is very, very important. Definitely you will get a question on CSMA bar CD and CSMA bar CA. Yes, so here we'll start with the transmission. Initially the backoff time is set to 0. So when it has anything to transmit, it will follow persistence strategy. You know what is persistence strategy? Wait or defer from transmission for a certain probability of time. Yes, so wait for some diffs time. I told you there are two time interval, one is sifs and another is diffs. Yes, so first it waits for diffs time interval and then will send the RTS packet which is request to send and will set a timer. Yes, until this timer expires, CTS is just an acknowledgement for RTS. Yes, so the same as what we have seen before. So until the timer expires, it will wait for CTS. Yes, if there is no CTS received, that means again it will wait for some random backoff time, and after which again it will sense the channel, and then if the channel is free, it will continue this. In case it receives an acknowledgement, then it will wait for a short time period called a sifs time interval and then will send the frame. Yes, after sending the frame, it needs to receive an acknowledgement. So it starts a timer again. Yes, and before the timer expires, if the acknowledgement is received, then it is successful transmission. Yes, suppose if acknowledgement is not received, what it should do? It should again increment the backoff timer, wait for the timer, and then it should again wait for the channel to be free, access the channel after certain time period. Yes, so just remember that CSMA CA is carrier sense multiple access with collision avoidance. Yes, in case of wireless channel, collision detection is not possible because we saw in collision detection there is spike in voltage level and therefore it is detected as collision. But in wireless channel it is not possible to detect any collision because there is always channel interference. Therefore you cannot detect any collision after it has occurred. It is only loss of packet or it is only loss of acknowledgement. What you can do is you can avoid collision as far as possible. So what you do in case of wireless channel, you have number of time intervals. Yes? So say as backoff timer, you wait for some random time before transmitting, you wait for some sifs time interval or diffs time interval before doing anything. Yes? So just each one has got different value. So initially it will wait for the channel, check if the channel is free, then waits for diffs time interval, send request to send packet and start a timer, wait for CTS packet. If CTS packet is received, it will again wait for SIFS time interval and send the frame and set a timer and wait for an acknowledgement. That means it is a successful transmission. On all other cases, again it should increment a back off time and then reset the timer and then again go wait for the channel and then it should transmit. Yes, so these are the two important protocols which we are using in case of wired and wireless channel.